So what if I told you there's a mathematical shortcut that's behind, well, almost everything, from how money grows in the bank to how fast information spreads online? It's called a power, and once you get the hang of it, you unlock a whole new way of seeing the world. To really get this, let's rewind a bit. We've all seen a problem like this, right? Repeated addition. Now, you could just add it all up. But, deep down, there's got to be a better way to write this.
And of course there is. It's multiplication. This is probably the first big mathematical shortcut we all learn. It's just a cleaner, faster way to say the same thing. But what happens when we level up from here? Now we've got repeated multiplication. And just like before, writing it all out like this feels kind of clunky, It's practically screaming for its own shortcut.
And here it is. This is a power. We'd say this out loud as 5 to the power of 4. This simple little notation is for multiplication what multiplication is for addition. It's the next step up, and learning its rules is a total game changer.
All right, so here's our game plan for today. We're going to start with the absolute basics, then we'll build up all the core rules. After that, we'll tackle a couple of the weirder puzzles, like negative and zero powers, before we wrap it all up.
Okay, first things first. Let's make sure we're all on the same page and get our vocabulary straight. Every power has two main parts.
It's really this simple. The base, that big number on the bottom, is the what. It's the number you're actually multiplying. And the exponent, the little number up top, is the how many times. That's it. Base is what, exponent is how many. Now that we've got the lingo down, let's get into the really cool part, the rules. We're going to start with the simplest ones, which are for when you're working with powers that happen to share the same base. So let's look at a real example. We've got 5 squared times 5 to the power of 4. Without doing any math yet, just take a guess. What do you think is going to happen here?
Well, if we just write out what each part means, we can literally see the answer. 5 squared is just 2 5s. 5 to the 4th is 4 5s. Put it all together, and what do you have? You just have 6 5s all multiplied together. So the answer has to be 5 to the power of 6.
And that little discovery points us right to our first major rule. Whenever you're multiplying powers that have the same base, that's the a here, you just add the exponents together. See? Our 2 plus 4 gave us 6. Super simple, and way faster than writing it all out.
So what about division? Let's try 3 to the 6th divided by 3 to the 3rd. Again, let's write it all out. We've got 6 3s on top and 3 on the bottom. You can see right away that 3 of the 3s on top are just going to cancel out with the 3 on the bottom. And what are we left with? Just 3 3s, or 3 to the power of 3. And I bet you can see the pattern here. This gives us our second rule, and it's just as clean. When you divide powers with the same base, you just subtract the bottom exponent from the top one. In our example, 6 minus 3 gave us 3. It's just simple subtraction. Okay, let's keep building. What happens when we start getting a little fancier? Like, what if you raise a power to another power? So if we have 11 cubed, and that whole thing is raised to the 4th power, that just means we have to multiply 11 cubed by itself 4 times. And hey, we already have a rule for that. We just add the exponents. 3 plus 3 plus 3 plus 3 gives us 12. And this leads us to our next big shortcut. For a power of a power, you just multiply the exponents. 3 times 4 is 12. The other two rules here are pretty similar. If you have a product, two numbers multiplied together, and you raise the whole thing to a power, you can just apply that exponent to each piece individually. Same thing goes for a quotient, or a fraction. The exponent gets applied to both the top and the bottom. These are super handy for simplifying things down the road.
All right, now for the part I think is the most clever. Up to now, all our exponents have been nice, positive numbers. But what about 0? Or negative numbers? What could that possibly mean? Well, it turns out we can use the rules we just learned to figure it out.
Let's start with a question that you have to admit sounds a little philosophical. How can you multiply a number by itself 0 times? It feels like it shouldn't make sense. But don't worry, logic gives us a perfect, concrete answer. Check this out. We're going to solve the same problem, 5 cubed divided by 5 cubed, in two different ways. On the left, we'll just do the math. 125 divided by 125, well, that's just 1. Okay, now on the right, let's use our division rule. We subtract the exponents. 3 minus 3 is 0, so we get 5 to the power of 0. So wait a minute. We solved the same problem and got two different looking answers, 1 and 5 to the power of 0.
Since both ways of solving it have to be right, that means the answers must be equal to each other, which leads to this incredible rule. Any number, as long as it's not 0, raised to the power of 0 is always equal to 1.
And believe it or not, we can use that exact same trick for negative exponents. Let's try 4 squared divided by 4 to the 4th. Using our subtraction rule, we get 4 to the power of negative 2. Okay, but if we write it out the long way and cancel, we end up with 1 over 4 squared. So a negative exponent doesn't mean the number is negative, it just means, hey, flip me over and put me in the denominator. It's an instruction to take the reciprocal.
Okay, awesome. We've just added a whole new tool to our math toolkit. So the big question is, where do powers fit in with the good old order of operations? PEMDAS. Let's take a look.
Here's the updated list. We all remember parentheses come first. But look what's right there in step 2. Powers or exponents. That E in PEMDAS. This means they have a really high priority. You solve everything in parentheses first, then you immediately calculate any powers before you even think about multiplication or division.
Wow, we have covered a lot of ground really quickly. So before we wrap up, let's just take a breath and put every single one of these new rules together in one handy place.
And here it is. This is basically your ultimate cheat sheet for powers. We've got our rules for adding and subtracting exponents when you multiply or divide. We've got the rules for what to do with a power, or a product, or a quotient. And finally, we've solved the puzzles of the negative and 0 powers. This is the whole toolkit, right here.
And let's end with one last thought to chew on. We started this by saying that multiplication is a shortcut for addition, and that powers are a shortcut for multiplication. You can kind of see a ladder here, right? Each new idea simplifies the one before it. So, what do you think is the next rung on that ladder? What's the shortcut for powers? Well, the answer is a concept called logarithms, and they are the next incredible step on this journey.